Hello everyone, my name is Karen Onti, part of the team RACQ-M1, and we are currently working on the design development of a roadside rest stop area. I've been assigned to work on the traffic circulation planning of the project. Its main concern is to facilitate motorists in entering and exiting the rest stop area. So I'm responsible for developing an overall road plan for the rest stop, ensuring that the route for the rest stop area is connected to the highway. This section contributes to the project development by planning how vehicles can access to the rest stop and designing road facilities to provide safe access to and from the area and highway. The main design task for this section is to develop a road plan that provides access to the rest stop from the highway and vice versa. So, this involves the entry and exit lanes of the route for the rest stop area, the pavement design for the road, which includes the thickness, width, and the slope of the road. The slope is also an important design task for the drainage system of the road, as it needs to be tilted in an angle to lead the rainwater to the drain. Arrangement of the parking lots for normal cars and trucks are also involved in the planning. A suggestive indication of where all the amenities will be placed is also made during the planning, but not having a great detail of the arrangements of the facilities, as we will do that as a group. So, I've managed to develop a good copy of the overall road plan by this point in time. As you can see, the plan incorporates the design for the route for the rest stop area and how it is continuous to the highway. So there it shows the traffic lanes of the highway. Each one is for vehicles traveling in opposite directions. There is also the entrance for the rest stop area as well as the exit lane. The entrance lane is facilitated with a diverging lane for vehicles traveling along the road adjacent to the rest stop area, as well as a turning lane for vehicles traveling along the road on the opposite side as they would head towards in the opposite direction. The exit lane is facilitated with a merging lane to safely merge onto the highway for motorists who intends to travel along the road adjacent to the rest stop area. There is also a turning lane that leads the travelers to a U-turn facility to safely make a U-turn if they wish to travel along the opposite road. The parking lots for normal cars are also indicated in the plan, which is shown to be diagonally designed in a 45-degree angle. And the truck parking lots are also incorporated in the design plan. The length and dimensions of the road are in compliance with the Road Planning and Design Manual and relevant off-road standards. The next few slides show the pavement design for different cross-sections of the road. Here is the pavement design for the road cross-section along the highway where the turning lane that leads to the facility is designed. The pavement thickness and width are indicated as shown. The road design is set to slope by 3%, which is a desirable value of slope based on research conducted. Here is another pavement design for the highway road cross-section that shows the pavement design for diverging lane and turning lane to the entrance of the rest stop area. Here is the pavement design for the roadway cross-section adjacent to the truck parking lot. Here is the cross-section for the roadway with the car parking lots and the truck parking lots on each side. This also indicates the arrangement of the drainage. The drainage was decided to be on each side of the roadway and length the same as the roadway it's situated at. Here is the cross-section for the diverging and merging lane. Both lanes will have the same thickness, width, and slope, but differs in taper length. I'm still in the process of documentation part of this section that will be included in the project proposal, as well as developing the cost analysis for the pavement design. I'll now hand you over to Scott.
Hi, my name is Scott Lane. I'm a civil engineering student and I'm in charge of the building and car park designs for our project. So far, the tasks I've completed are the designs for the shelters, the amenities building and the car park. I've also chosen the construction materials. All I have left to do for this project is determine the concrete slab specifications, estimate the material and construction costs, and integrate my colleagues' work on the water storage, energy and lighting systems into my final 3D model of the shelter. So here you can see the current iteration of one of the shelters. There'll be two of these, mirror images of each other, distributed throughout the rest area. So a minimalistic design was chosen to reduce construction time and materials cost. The frame is composed of steel I-beams, with the remainder being made from wooden beams. On the upper half of the walls, you'll notice there is a wooden lattice, which provides shade and shelter for the barbecue area without reducing visibility of the park, which is necessary for safety purposes. This conceptual model shows the layout for the car park and the building configuration. The buildings have been positioned to allow a clear view of the car park and the rest of the rest area. We are currently contemplating putting a playground in between the two shelters. The car park allows space for 4 very large trucks, 8 medium-sized vehicles, and there are 2 disabled car parks. So as you can see, the civil section is currently well on track, and we will have this completed by the 27th of May.
Hi, my name's Levi. I'm working on one of the mechanical sections for this project, and I'm in charge of designing the solar hot water and piping systems for our rest stop. So what has been completed includes research outlining the details of the type of solar hot water system that will be used, research on the sizing and materials to be used for the piping system, a draft drawing of the solar hot water system, and calculations determining the sizing and layout of the piping system. The tasks I still need to complete include a final CAD drawing for the solar hot water system and draft and final drawings of the piping system. This is a diagram of the solar hot water system attached to one of the shelters. It outlines the size and positioning of the tankless water heater and solar thermal collector. So as you can see, this mechanical section is not far from completion and will be finished by the due date, 27th of May. Thank you.
Hi, I'm Guilherme Mendoza and I'm doing the rainwater collection for the mechanical part of this project. So far what I've accomplished to do is to finalize the system and the type of water storages that we're going to use for the rainwater collection, and the materials for the roof and water storages has also been finalized, considering the most efficient and most cost effective. The location of the water storages on the main design is also done, and I've collected some rainfall data on the area that we're going to put our design project. The other things that needs to be done in my part is the water consumption data, which will allow me to finalize my dimensions on the water tank, also the costing of the materials, and the final CAD drawing for my rainwater system. There's a small picture there just to show the draft of my rainwater system. I will now hand you over to Liam and Brock, who will talk about the electrical progress.
Hello, my name is Brock Owen, and along with Liam Edwards, I am doing the electrical section of the RACQ project. So far, I've progressed with specific research into the Australian standards for the isolated power supply. I have also determined the solar exposure for 3 areas along the Queensland coast, including Rockhampton, Cairns and Mackay, which I've passed on to Liam for the use of the power calculations. I've also completed a detailed circuit diagram showing how power is formed on the solar panels, stored in the battery and then distributed around the rest area. Still outstanding are determining exact values for the storage device, and hence picking the storage device and determining the cost. I also have to do an overall electrical plan for the whole site using AutoCAD. As you can see on the next slide, it just shows the solar exposure data that I've found, and this slide after shows the electrical circuit diagram, which I made in AutoCAD. Great progress has been made on my part, and I'm satisfied that our team can finish well before the due date. I will now pass on to Liam to finalise the team's progress by discussing the final electrical section. Thank you.
I am Liam Edwards, and as Brock has just mentioned, I am responsible for some of the other electrical aspects of the project. The electrical tasks that I have completed thus far include the lighting of the rest stop area. This includes lighting both the undercover area and the toilet box, as well as the car park. The undercover area and the toilet box will both be lit by four 18-watt light bulbs. These kinds of bulbs provide sufficient lighting and will require little energy from the rest of area's solar panels. Not only that, but they are very inexpensive at just $3.97 per bulb. For the lighting around the car park, I have researched different types of lighting and have selected 6 24-watt LED lights. Each of these will cost $458.84. As for the barbecues, after some research, it has been determined that the barbecues will be gas-powered, not electric. Due to the myriad of locations that this rest stop area could be installed in, it seemed unlikely that the barbecues could be sufficiently powered without an expensive solar system. This may incur additional costs that are still being determined, such as the cost of gas and maintenance. This slide shows all of the electrical components that are going into the rest stop currently. And based upon these projections and the solar data from Brock, I have calculated that to sufficiently power these components, the area will need a 5 kilowatt solar system. Early estimates from quotes have suggested that this system will cost approximately $11,000. As you can see, we are progressing nicely with the project. We are currently on schedule and are confident that we are able to reach our 17th May deadline for this project. Thank you for your time.